Hello, my dears. I am at your service in another session of robotics training, and from this session onwards, we are going to do practical work. The topic of this session is controlling robotic motors so that you can learn how to control motors in robotics. The first project for controlling the motor is that we can move the motor of a robot in different directions. And in fact, if we are going to build a robot that is supposed to go forward and backward or move left and right, for example, we can change the direction of this motor using two generalities. And in fact, we can also rotate the motor in two opposite directions. To build such a circuit, we need to first use a law called Paul's law, which is also called the remote control in the form of a ladder. Now, why is it called a ladder? I will explain this in the continuation of your service, but in the whole circuit you see. This allows us to rotate a motor in two different directions as if I were changing the negative of the motor to the positive. So we'll start by explaining the plan to you first, then we'll go into Protos and implement it in a practical way. And then we'll go into practice and build the circuit and connect a circuit to it to see how it works. The prerequisite for this session is that you know Protos well, and since it's not just robotics training, you have to learn the software and Protos separately and know how to work with it. So let's move on to the explanation to see what our circuit looks like. As you can see, and you also have to know electronics well. Here we have 4 transistors that you can see in their symbols. Each of the transistors has a 1 coulomb resistor, which is connected to their 20th pin. Then we have 4 diodes, they are the same stray diodes and are used as stray diodes here. And if I were to say what a stray diode is, it is actually a diode that when the power to the transformer is cut off and it stops rotating, causing a vacuum-like rotation that creates a reverse voltage. This reverse voltage can damage the transistor and cause it to burn out. But when we use a freewheeling diode, as you can see, look at the diode, how it's connected to the motor. Well, look at this motor, right? Calculate it from any angle. Finally, it's connected to a diode. When this motor it actually creates a leakage current. And from this leakage current, a voltage is created. This voltage enters the diode and is consumed by the diode, so it no longer reaches the transistor to cause any damage. On this account, they are called rotating diodes, which we even have in relay coils. So the transistors and rotating diodes that we have here, you can also see the motor itself in the middle, which is actually a motor that we are going to control. And this circuit of ours naturally has an input voltage section and a negative positive circuit. These black ones that you see here, the black buttons, are actually the same as our general ones, and I'll show you how to connect them. Well, for example, if we press this, the motor will turn to the right, and if we press this, it will turn to the left. Now let's get to the explanation. If you pay attention, for each of these generalities, a connection has been made from the positive side of the circuit. One to this connection, and one to this connection. Now, what is this power connected to these components? Because when we press this component, each of these components must actually send a signal to the base of its corresponding transistor and activate that transistor. You know that when a transistor's base receives a signal, it becomes active, and then it switches and acts like a whole, right? So we need to give them a signal, which we do using the base CC voltage, which we have created for each of the holes. What happens when we press this right turn switch? Look at which transistors this right turn switch activates at the same time. You can see one transistor here, which I called Q4. Another transistor here in a cross pattern actually activates these 2 transistors. Now what happens when the transistor is activated in a cross pattern? The voltage comes in from here, right? It passes through the transistor here. It passes through the motor and then passes through this one transistor and connects to GND. In fact, our circuit is closed in this way. So when the circuit is closed like this, what happens is the motor starts to rotate in a certain direction. Now, let's say we're looking at the right direction here. It starts to rotate in the right direction. Now, if we turn off this switch and press this switch this time, what does this switch do? It activates this transistor, and these 2 are turned off, so these are activated. So what happens again? The voltage comes from here this time, passes through this transistor, enters the motor from here, exits this transistor, and is connected back to the generator. And in other words, the circuit is closed like this, so the motor starts rotating in the X direction. It's like this. Once we apply positive voltage to this leg of the motor, And this time we cut it off. We apply positive voltage to this one, meaning in the negative position of the positives is constantly changing. And when this happens, naturally the motor will rotate both clockwise and counterclockwise. And with this simple circuit, we can easily control the direction of the motors. For example, our robot can move left and right or forward and backward. For example, if you have two of these H circuits, you can actually control a robot and make it move forward and backward and left and right. Don't look at this circuit as simple as that. You can say that this is the basic circuit and its scope is like this, but later we can expand it and even control it remotely. Now we will deal with that. Wired circuits, and in order for you to learn the full depth of the circuit, because as I promised, this robotics course should be a practical course. You should know the depth of the robots and know how a circuit works, not just ready to use. That's why we will first explain the scope, and later in the next session, we will implement a much more advanced model. And for example, I would say that the advanced model is like this. If we put a microcontroller and use a mobile phone to send the left and right commands to the microcontroller, control the transistors, and the transistors will also control the speed of the motor, which we will also build and you will learn. So this H-bridge circuit, which I now call the H-bridge, is called so that you can see that it is somehow, as you can see here, the symbol that I created actually looks like the English letter H. And that is why they say money, which is actually in the form of money. This transistor becomes money with this transistor, and this transistor becomes money with this one. That is why they call it the H-bridge. And in fact, this circuit can be said to be a kind of copy of each other, and with this circuit, well, as it was said, we can control the motor in different directions. And now, I want it to be so that we can implement this circuit in the Power 2s to see how it is, because in the Power 2s, we can get a practical taste of it. Let's go to the Power 2s and see how our circuit works. I open the Protos software here. As you can see, then we need a few parts. The first part we need here is to select the parts. I will put this section in the transistor. For example, here you can see that I can choose the types of transistors. For example, I will choose the BC Ponce from the 47, which is the simplest transistor for our work. I will double-click it to add it here. Then what do we need? We need a DC meter, which I knew here was a meter, and you can see that it brings me a meter. After the meter, I need a diode. Here, when I put the diode, it brings me a diode. Now let's see. When I choose the diode, it doesn't make much difference. The purpose of the diode is, for example, I will choose this. Then I need a button, which is also a push-button switch. When I find the push-button switch here, I will load the push-button switch. So let's see what else was needed. We added the diode. We need it in front of you. I choose a position, and for example, I'm going to read a position. I don't want a potentiometer position. I choose a normal position like this, and I think it's complete. If I'm not mistaken, it's complete. Then I need a negative voltage. Well, now we'll put them in. So, from now on, we've chosen our parts. After we've chosen the parts, what are we going to do here? First, we'll put our transistors in exactly the way they need to be. This is how we'll put these transistors in using the router. We'll put them in this way. We'll draw them in this way. Well, here. Then we'll put the mirror back in so that it's in the way I want it to be. Well, from now on, I'll put the diode in. We'll connect the diodes like this. Exactly the same way. Here, here, and here. After the diode, I'll put the resistors that are connected to the base of the transistors like this. Well, look at each of these resistors. They're 30k ohms, right? We can edit them very easily. I'll come here, for example, instead of 30k, we'll put ONEC, so it's ONEC ohm. You'll see it's changed to ONEC. Right-click and click Edit Properties, and instead of 3, we'll put ONEC. Just be careful how you do it. The circuit layout in Protos is kind of like Protos' tutorial. 1 and this one should be the same here. 1, so now our positions are ONEC ohms. Then we'll do the same connection. Here and done. We'll select the type of resistor. I'll select DC. Here, this is DC power. And here, I'll select the Jin Doi. After doing this, I'll now do the wiring. I'll do it. I'll pull a wire from D. I'll pull it like this. It'll reach the transistor. In fact, the purpose of the transistors is like this. And this transistor, I'll connect it to the D pin. This from this, again like this. And I'll connect these together. They'll be connected together. So this from this. If you wanted to make a wire, for example, you can do this. In order for the transformer to come out, I'll connect it like this. So this from this. Now the diode must be connected. This diode to this diode like this. The next one is the same. So this from the magnetized diodes, a connection like this is necessary for each of the transistors to be connected. Then we'll put the motor in it. I'll turn the motor like this and one turn. So now we'll connect the motor like this and like this. This is the motor. Then we'll take one from this voltage source and put it there. Then we'll put one here and put it there for the keys. In fact, after that, we also had push buttons. That's right. We'll put these keys like this. They put one key here, Partis. That's enough for him. They put one key here. This key didn't connect well. I'll start over with a cleaner wire. So these are the keys. Now, what do I do with these keys? So look, I'm going to connect one to this. I'm going to connect one to this transistor. I'm going to connect one to this transistor like this. Is that how you actually make money? I'm going to put this one in this position. One to this, one to this. That is, I actually press this switch and the motor turns left and right. That is, when I press this switch, this transistor and this transistor turn on. And when I press this transistor and this transistor turn on. After that, I will also define the voltage, for example. What voltage do you want? I will right-click here, then I will click the edit button. The voltage type will be DC, and for example, I will choose 12 volts. After I selected the voltage is 12 volts, I will run the project. Here, I will click on this run button. We can see that our project is running. The motor is turned on, which means that we now have electricity. Now I'm going to press this key. I'm going to press this key. You'll see the motor is turning to the left. Now I'm going to release it. I'm going to press this key. You'll see the motor is turning to the right. So now we have created the circuit in a completely practical and correct way. In fact, the circuit of bridge, for H, for example, if I press this button, I'll hit this and let it stay like this. You'll see the motor start to spin. It's like we pressed and held this button and you'll see the motor is spinning. Now why is it spinning slowly instead of, well now Protus isn't going to simulate the real motor anymore, right? Just a simulation. So now we have a circuit that we can use to control the direction of the motors. Now, to make this a reality, we're going to implement my circuit on a breadboard and see it in practice just before we get into it. Let's make a circuit and get into a practical example. Keep in mind what kind of motor we choose and what voltage and amperage it consumes. Based on the motor, we must also choose the right transistors, for example, since now we have robots working with 5 volts, 12 volts, and finally, they are working with 20 volts. On this account, the transistors that we chose here, for example, 20,547, are enough for this voltage. And our type of motor is usually armature motors and small DC motors. So this circuit is enough, but if the more powerful our motor becomes, the more amperage and voltage we want to connect to it. Naturally, the diodes and transistors we choose must be more powerful. So with this knowledge, we will move on to the practical implementation of this circuit and observe it so that we can end this session, and I hope you have learned well. The only thing that is needed is to practice very carefully and a lot to fully understand the circuit. In this session, I tried to explain what is necessary in the shortest possible time so that you can understand the circuit and use the circuit well. Let's go to do the practical project. As mentioned, I want to test this circuit, the H-bridge circuit, in practice so that you can see. I implemented the circuit here with the same 547 transistors that we drew on the prototype. You can see the diodes and the resistors that you easily have. You can see, and these are actually our circuit. Now let's test it. I put 2 sets here. One of these sets is on the left, and this set is on the right. And I use the motor that is also used in robotics, which is actually a geared motor. I will make it so that it is easy to see. Please pay attention to this part of the motor so that it is easy to see the rotation of the motor, and you can see the directions of rotation here. So I will first press this switch. You will see that it rotates in that direction. I will press this switch and press this one. You will see that it rotates in the opposite direction. This means that my circuit is working well. I will test it again. You have seen the test. And just like that, you can implement the circuit and use it. So here we were able to implement the first robotic system that is for controlling the motor. In the next session, we will not go into how we can control the speed of the motor, and in fact, how fast the motor should run. How can we control it ourselves and be able to use it well? Let's use it, but before we enter the next session, which will be our next 2 sessions, I want to introduce you to a moment of motor speed control. And that is that there are ICs in the market called H-bridge ICs that you can use those ICs. I came here to explain this circuit in this way so that you can understand the depth of the operation and actually know how to build a circuit even without an IC to control the motor. But if you want to build a real circuit for a robot, I myself recommend that you definitely use the H-bridge IC, as you can see in this image here, which I have provided for you. These ICs are the same circuit. The area of this circuit has been integrated, and there is no need for you to come and design the circuit and put a PCB on it. You can directly use the same IC in your circuits, and the inputs and outputs of each IC are completely specific, meaning you just need to look it up on the internet and see the datasheet. Where should you power it? And where is it controlled? Of course, in future sessions when we get into more advanced material, I will teach you all of this myself. But it is much better if you do a pre-test yourself, and it will make you. You can use this course more easily in the Dianda session. Thank you for being with us.